Of this screencast is to discuss the terminal and the shell, and you might also hear that called the console. And these are alternative ways of communicating with your computer that I think you'll find very powerful, if not more pleasurable. Of course, computers originally were created from vacuum tubes. That's before we had transistors and before we had integrated circuits. And these things were large. A computer built from vacuum tubes might take up a whole room, and it had to be serviced by many people. You might wonder, how did they communicate with these computers? Well, they used punch cards. And those punch cards were based on technology that predates computers. So if you look at this young woman here, she's dealing with a computation machine that knows how to add numbers and do fancy math and stuff, but there's no electronics involved. Instead, she's creating a punch card that encodes various algorithms for various different kinds of maths. And so initially, we used punch cards to communicate with our computers, which were powered by vacuum tubes and later integrated circuits and transistors. So this man here is describing how to program a computer in the 40s at the Census Bureau. Later on, the punch cards got fancier, and so you can see this man pulling out what is essentially a giant, long, thin punch card that encodes some kind of algorithm on a reel. And we would store these reels in giant warehouses. Eventually, the punch card makers got integrated with computers, and that became essentially a typewriter of sorts. And so you can see these women here encoding instructions to go straight into the computer. Of course, eventually the keyboard became integrated into the computer itself, and this is what you would refer to as a console. So here you can type in a program into the computer, and it would execute it. You're looking at a Zenith Data Systems console from probably the 60s or 70s here. Soon, Xerox invented the graphical user interface, which is seen here in the Xerox Spark, a computer that was introduced in 1975, incorporating many of the advancements that were developed for the Xerox PARC computer, including menus for a certain limited number of operations like opening files. It also includes the first what you see is what you get text editor here, which you can see on the right-hand side. Shortly thereafter, in the early 80s, Apple introduced the first Macintosh computer, which you can see here, and a desktop that probably looks familiar to you that includes Mac OS X icons that, or not OS X, Mac OS icons that are not dissimilar from what you maybe grew up with or recognize today, including the Apple at the top left-hand side of the screen here. And so now, most of us have grown up in a world where we think of interacting with computers as just clicking on things. And that doesn't matter if you're using a Mac, it doesn't matter if you're using an Android device, or you click on stuff, right? It doesn't matter if you're using whatever the hell kind of interface this is, right? The paradigm is that we're clicking on stuff and we're not typing to the computer. We're not using a terminal and communicating with it on its level. And the truth is, that's a real shame because it's highly limiting in what I can do with my computer, right? I can click on my Finder and I can go to my documents and look at particular files. But, that's pretty much all I can do in this interface here. Or if I open up some sophisticated program like Microsoft Word here, and you look at the menu, you can see that, well, maybe I can do a few hundred things, but can I do a few thousand things? And the truth is, the software supports many tens of thousands of operations, but only a small fraction of those are exposed through this graphical user interface. Much more is exposed in most of the programs that we can use through the terminal. And of course, I don't have a terminal connected to my computer anymore, but what I do have is a terminal emulator. And on my Macintosh, that exists here. Inside Utilities down there, there's a program called Terminal. And when I click on that, it brings up this little window here. Now, on my terminal, it runs a shell when it first starts up, and my shell is called Z shell. There's other shells that are older. There's one called C shell and the Bourne shell, Bash, T shell, all kinds of shells, and that's the little program that runs inside this window that makes those fancy colors and gives me this prompt, and I can type stuff with this prompt. Type something that doesn't exist. So there's a command not found. Z shell says, hey, can't find that thing. I can type commands that do exist. So ls, that lists the files that are here. I can change directories, and I can create an empty file with the touch command. So I just touch Kyle there, and I can do head Kyle.txt to see what's at the top of Kyle. There's nothing on his head. That happens to be true in real life as well. And I can type the tail command to see what's there. I can type the cat command to put stuff into the Kyle file. Let's see. And now when I type tail Kyle, I can see all those lines. I can do tail show me the last 2 lines of the Kyle file, and I can see the last 2 lines. There's many commands that I can type, and a lot of them live in a certain directory. So I can list the things that are in user bin. These are binaries, hence bin, that are for use by users. And you can see there's a ton of programs that you probably did not know exist on your Macintosh. So for example, Pico, which is an editor. Font restore, I have no idea what that does. Format, which is a nice thing that formats lines. So I can, for example, format the Kyle.txt file, and you can see it's taken those lines and concatenated them. There's a program called less, which allows me to look at the Kyle.txt file, and my shell gives me all sorts of shortcuts for navigating around and being a total ninja in the terminal or on the shell. So for example, $$ brings up Kyle.txt, which was the last thing that I typed in the previous command. And so the less command, less Kyle.txt, gives me this little view of this file. There's another command that does the same thing. It's called more. Although, as you'll find if you use the two, less is more. And there's all sorts of other programs here. And truthfully, I don't know what 90% of them do. There's a small fraction of them that I use. And you might enjoy exploring what is there. So there, for example, is a command that I use frequently called grep. So I want to look at, show me the lines in Kyle.txt that contain an S. And that shows me all those lines. I think there's probably only 1 or 2 that contain an L. Let's see. 3 lines contain an L, you see? And there's other things I can do. I can do word count of Kyle.txt, and that shows me there's 58 characters, 5 words, and 5 lines, okay? I can do WC minus L, which show me just the line count. And so all these commands that exist on the command line where you have access to them have different flags, and you can learn about those flags frequently by just typing the command, well, although not in that case. Or you can do the manual page, so man WC will show me the manual page for the WC command, and it says WC, word, line, character, and byte counter. The WC utility displays a number of lines, words, and bytes contained in each input file, blah, 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 and down at the bottom it shows me all the flags I can provide. So this is called a flag here, a dash and then something. So you saw me use the -L flag, which just prints the number of lines. It doesn't do the other computations. And so there's many commands that we'll be using throughout this semester. Well, many is not the right word. There's a handful of commands we'll use throughout this semester, and mostly it's the simple stuff like ls, list the files that are here, cd to change directories. You might use the touch command to create an empty file. And one command that you use a lot is a very sophisticated program called git. And I have git installed on my computer, and I can find out where it's installed by typing which git. And it shows me that when I type the word git, it will find the git that is located in user bin git. So which tells you which programs are in your path. And a path is the areas on your computer where your computer will look for programs. So most of you probably think that programs live in library applications in your Mac or wherever the hell they live on a Windows machine. And there's a lot of other programs that live in user bin. There's some other programs that live in user local bin. And those are ones that I have installed. And in this case, I need to use the sudo command to do that, but I'm not going to type my password for you here. And sudo makes me a super user, which is the kind of person that can nuke your computer. So ordinarily, it's a little bit tough to mess up your computer, and you don't have to worry about stuff. So if your cat walks on your keyboard, you don't have to worry about it. Once you type sudo, kind of all bets are off. So you only want to type it in certain situations where you need special permissions to either look at files or edit files that are require some modicum of safety. So back to Git. Git is a program we'll use in this course for version control, and we'll be using it a lot. I have Git installed on my computer at user bin, and when I type Git without any arguments, what you can see is that it prints out help for me. It says basically this is how you should use me. The usage is Git, and you can give it all of these flags, and the brackets here mean that they're optional. So I could optionally give it the version flag. So if I did Git version, it tells me this is Apple Git 50 1.9.3, and I can do other things. I can give it all these flags, and I can give it commands as well. And what you'll see in the homeworks in the project is that we'll be using Git extensively to do things, and we will always do that on the command line. And the reason is that Git was written for the command line. There are various GUIs available for Git, but it really dumbs it down. and it doesn't do a good job at dumbing it down, which is to say that if you look at Git GUIs, you'll find they have a lot of menus and a lot of complicated things that you won't understand, so you might as well learn to use the command line when you're using Git. Now, clearly, terminal emulators don't exist just on my Mac. Here's my Linux desktop, and you can see on the top right-hand side here, there's a little nice transparent terminal emulator in which I'm editing a text file. There's even a command line prompt on Windows machines, although it works in a substantially different fashion than what I described to you today. And of course, this semester we'll be using the Cloud9 IDE, or Integrated Development Environment, to write our code and to run our programs. And Cloud9 has a built-in terminal emulator inside of it. So here I'm in the terminal, and I can type all sorts of crazy stuff in their little isolated cloud environment. I think you'll find the terminal to be a very pleasurable thing. You shouldn't be afraid of it. It's very fun, and it's literally like plugging into the Matrix. Once you try it, you really can't go back, and it's really great for impressing your friends.